In this lecture, we're going to revisit our C++ program compilation model. Along the way, we are also going to see how we can work with functions across multiple files. If you remember, our compilation model looked something like this. You have seen this slide a lot of times by now. What it describes is what happens when we compile our program. The moment we run the compilation command, our C++ program, which lives in the main CPP file by now, is going to be passed through the compiler. The compiler is going to process it, and it is going to come up with a binary executable that is mostly called rooster in this course. And when we execute this rooster file or binary file, we're going to get the program to run. The program is going to be executed instruction by instruction when it is loaded by the operating system, and we are mostly going to see the output of that program on the terminal in this course. This is the compilation model we know. But now what we want to do is zoom in on this compilation part here and see what really happens under the hood. We are going to suppose that we have our program which is made of a lot of source files as we have here on the left. Suppose we have 2, 3, or 5 source files, unlike what we have so far, which is one file, the main CPP file. When you compile such a program, you're going to go through a stage called pre-processing. And what this is going to do, it's going to look for your include statements, and it is going to take whatever file you are including, and it is going to paste that in place. So for example, here you see we have an include IO stream statement. When the pre-processing stage is run, this include statement is going to be replaced with whatever we have in this IO stream file here. So this is going to be wiped out, and we're going to put in the content that we have in IO stream in this exact place where we have the include statement. I hope this is clear. So when we go through pre-processing, we're going to have a version of our source files with the included parts put in our source files. We're basically going to go copy everything in that file that we include, and we're going to paste inside our new files here that we're going to be referring to as translation units by now. These are translation units in a C++ program. Once you have these translation units, then you're going to compile them. They are going to go through the compiler. The compiler is going to generate what we call an object file, and this is a binary representation of the content you have in your translation unit. So each translation unit is going to generate one object file. And for example, if you had 20 translation units in your program, you're going to have 20 object files. Once we have object files, they are going to be processed by what we call the linker. And the linker is going to stitch them together and have one single binary file out of all these object files. So we're going to have something like this. And this is basically going to be our binary that we can run on our target operating system. So by now you see that our compilation model has expanded to contain 3 phases. We have pre-processing, compilation, and linking. Now you might be asking, why am I showing you this now? Well, it is going to matter because we're going to split our program across multiple files. Some of those files are going to matter on the compilation phase, and some of those files are going to matter on the linking stage. So we really need to make a clear distinction between compilation and linking here. Okay, this should be a more complete compilation model to go by for now. Now that we know about this compilation model, we can look at how we can split our program across multiple files. Suppose we have 3 functions. One we can use to get the maximum of 2 numbers called max, a function called min we can use to get the minimum between 2 numbers, and a function we can use to increment and multiply like we have seen in the last lecture. Now the 2 functions max and min are going to live in their own file, and that file is going to be split in 2 files. We're going to have a header file and a CPP file which is going to contain the implementation. In the header, what we're going to have is just a prototype. And we are going to set up our code in a way that our incr mult function here is going to live in its own file. We're going to split that in 2 files. So we're going to have a header file called operations.h, and we're going to have an implementation file called operations.cpp, which is going to contain the implementation of this function here. When we hit the main file, what we're going to do is nothing special. We're just going to include the headers, and we are going to use these functions like we have been using them all along. If you look on the first line here, we are calling max. On the second line, we are calling min. And on the third line here, we are calling increment to do whatever it does. Okay, when you start splitting your functions between definitions and declarations, remember the one definition rule. And this says that you can't have a function defined multiple times in your entire C++ application. If you do that, the linker stage is going to find those two functions, and it's going to not know which one you really want to use, and you're going to get a linker error. We're going to see that when we hit Visual Studio Code in a minute. Another thing is that you know that your definition can really live anywhere in your code. The linker is smart enough to parse your entire project looking for the definition for whatever function it found in your source code, and it's going to keep looking until it finishes looking in all translation units, and when it doesn't find the definition, it's going to give you a linker error, which is probably going to say undefined reference to something, and we're going to see an example of this in a minute. Okay, now that you know about this updated compilation model and you have an idea that we can split our functions across multiple files, we're going to head over to Visual Studio Code and play with us. Okay, here we are in our working folder. The current project is multiple files here. We're going to grab our template files. Let's copy that and put that in the project of interest. And we're going to open this in Visual Studio Code. Let's do that. We're going to open the folder. We're going to choose the project and open it. And we are going to open up the main CPP file here and clean it up a little bit. We are going to set up a max function. And remember, the function has to show up before it is used somewhere. And we are going to split this into a definition and a declaration. I think we already know how to do that. So let's do that. We're going to put a definition down here, and we're going to change what we have on top here into a declaration. Let's say that to be super clear. And what we have down here is a definition. And we can call this function. We're going to set up a variable which is going to store our max, for example. And we're going to assign whatever we get from the function to max here. So we want to find the maximum between 34 and 56, for example. And we're going to print this out. We're going to say max is the maximum. And if we build and run this program, let's use GCC to do that. We have a compiler error here. What is that? We need a semicolon, not a colon here. I think the squiggly line is now going to go away, and our things are named the same way. The compiler is not going to like it. Let's bring up a terminal so that we see our problems tab, expression preceding parentheses or paracal must have. Okay, the problem here is that these two guys, max and max, are called the same, and this is going to confuse the compiler a little bit. So what we're going to do is call this maximum. No big deal here. And we're going to do maximum here. And the compiler is going to be happy. Now we can compile and build this program. Build is good. And if we run it, we should get our maximum printed out. Let's see that the maximum is 56. And if we change 34 here to be 134 and build again, we should grab that as the maximum. Let's see if that's the case here. Run the program. The maximum is 134. So this is working exactly as we want. The next thing we want to do is to split this function across multiple files. So we're going to set up two different files. One is going to be a header file. The other is going to be a CPP file. And you have to follow this structure in C++. So we're going to go on the left here and add a new file. In Visual Studio Code, you can click on this little icon that says new file to create a new file. Once you do that, you're going to be given this little window in which we can type the name of the file. We're going to call this compare.h. It's going to be our header file. And we're going to add another one, which is going to say compare.cpp. Okay, our two files are going to be compare.h and compare.cpp. And they are going to contain our functions to compare stuff. So we're going to have a function called max and another function called min for computing the minimum. Let's go there and actually do that. We're going to move our declaration in the header file. So your declarations are going to be living in header files, and we're going to grab our definition and move that in another file called compare.cpp. So I'm just going to cut it out and paste that in compare.cpp here. Once we do that, we're going to go back in main and see that we have a problem now. The main function doesn't know what this max function is because it's not declared anymore. And if we're trying to compile our program, we're basically going to get the same error we see here in Visual Studio Code. Identifier max is undefined because it doesn't know what this function is. If we ignore this and try to build, let's do that. We are learning, so no big deal here. We're going to get an even much weirder error. But the message is going to be the same. Max was not declared in this scope, so the compiler doesn't know what to do with whatever we typed here. But there is a way in C++ we can solve this problem by including the header that contains our declaration for the function that we are using here. We can go back in main and do that, and we're going to say include, and we're going to say compare.h. That's going to bring in our header. And if you wait a minute, you're going to see that the squiggly line is going to go away. So what happened, the preprocessor is going to come in and copy whatever we have inside compare.h. It's basically going to go in compare.h, copy everything we have in here, and come back in main and paste all that in the place where we have the include directive here. This is called an include directive, or an include preprocessor directive. This is what the preprocessor is going to do here. And now if we try to build this program, let's try to do that. We should be fine. Build, finished successfully, and we can run our program to see the maximum printed out. Let's run rooster. Maximum is 134. Now everything is working. Let's add another function here because just having one function is really boring. So we're going to put in a main function. It's going to take int a and int b, and we're going to go in the CPP file and put in another definition for the minimum function here. We're going to call this min. Let's do that. Let's call this min, and we're going to test for a is less than b. This is going to give us a minimum. And now if we go back in main CPP, we will be able to use our minimum function because it is brought in also by this preprocessor directive we have here. So we can go down and say int minimum, and we're going to say min, and let's grab 146 and 23, why not? And we're going to print the minimum here, and we're going to build this with GCC. The build is going to be good. If we run this, we should see both the maximum and the minimum from these calls we make here. Okay, by now you should have an idea about how to split your functions across multiple files. You should also know that you will have to include whatever header contains the declarations for the functions that you want to use. Another thing I want you to see is that the definitions for your functions don't have to live in a file that is named the same as the header file. For example, here our header file is called compare, and compare.cpp contains our definitions. But the definitions don't have to live here. They can really live in any translation unit that you have in your C++ program. In our C++ programs, the translation unit is mostly equivalent to a CPP file. So let's set up another file and show you that we can move this definition there, and the program is going to keep working. We're going to add another CPP file and call it some other file .cpp. It has to be a CPP file because it's going to contain the implementations. And let's take the implementations, for example. Let's take them all and put them in another file. Why not? We're going to grab all these guys here. Let's cut them out and put them in some other file. And we're going to build this and see that it works. It should, because the linker is smart enough to go find these definitions and whatever translation unit that we have set up in our project here. And you see the build is good. We can build this, we can run this, I should say, and we're going to have our output here. We can even take one of these guys, let it live in our compare.cpp file. For example, let's take the minimum function here, and we're going to bring that back, and we're going to build. Notice that now our maximum function is living in some other file, and the minimum function definition is living in compare.cpp. But if we build, this is going to work. Again, the linker is going to parse all the translation units looking for whatever definition it needs to find. And in this case, it will be looking for the maximum here, and it's going to find that in some other file. And for the minimum function here, it's going to be looking and compare, and it is going to find it. And the build is going to be good, and we can run the program again and see our output here. One thing I really need to point out is that if the definition is not available, let's say the minimum function here is not there, we can comment it out to hide it to the compiler or hide it from the compiler. And if we try to build now, we will get a linker error. Let's try to build with GCC. Build finished with errors. The terminal process terminated with exit code -1. But the main message here is that we have an undefined reference to min int end. So when we compile, the compiler is going to be happy with the declarations that it has found in our compare.h file. If we go there, you see that we have a declaration for max and a declaration for min. The compiler is going to be happy. It's going to compile our code. And when the compiler compiles, it's going to generate object files, and it will hand the job over to the linker to stitch all those little object files together to have one single binary file. When the linker tries to do that, it's going to look at main, because that's where it's mostly going to start from. And it's going to see, main is calling minimum here. Where is the definition for the minimum function? It's going to parse every single translation unit in the project. It's going to come here in compare.cpp, it's not going to find it. It's going to look in main.cpp, it's not going to find it. It's going to look in some other file, it's not going to find the definition. And the linker is going to say, I didn't find my definition for the minimum function, so I'm going to throw a linker error, and you, the developer, you're going to fix this problem. And you're going to see this error here. And again, this is a linker error. GCC doesn't give you more visible stuff to show you that this is a linker error, but what you should look for is LD returned 1 here, because LD is the linker that GCC uses. So this is a linker error. I think I should show you how a linker error looks if you are using a Microsoft compiler. So we're going to build again, but now we're going to build with MSVC. If you don't have Visual Studio, that's not a problem. You can keep using GCC, but I just want you to see how different compilers handle these errors. I have the luxury to do that because I am developing this course on a Windows machine, and I have a Microsoft compiler handy that we can use directly from Visual Studio Code here. So I am going to choose this compiler, and you're going to see that it is going to start building. It is building. And it is going to fail and throw a linker error also. So you see here some other object file. Okay. When this object file was being taken and stitched together with other object files to put together our binary, it didn't find the definition for the minimum function, and it is going to throw a linker error. And in Visual Studio, you're going to have a problem like this, LNK, and it's going to give whatever version of the compiler you are using. But down here you see unresolved external symbol. This is how Visual Studio says it. And it's basically going to be an undefined reference to something. This is just Visual Studio's compiler's way to say this. And again, it's going to say this is a linker error here. It is basically the same error we saw when we were using GCC in a minute. Visual Studio, the compiler from Microsoft, is also going to put a lot of junk in our folder here. So let's remove all these things. I'm going to select them all and I hit delete here. And they are going to go to my recycle bin. And we have another one here we should remove. Let's remove it. And now we should go back in some other file, .cpp or compare.cpp. That's where we have our minimum function. We can activate it. And if we build now, the build should be good because the linker is going to find this definition here. Okay, let's build with GCC because that's my favorite compiler. Now you see that the build is good. We can clear and run Rooster, and our program is going to work as it should. This is really how you can split your functions across multiple files. The headers are going to contain the declarations. The CPP files are going to contain the definitions. Your definitions can really live anywhere. It's going to be a matter of what works better for your project. But for organization purposes, your CPP files are going to be basically like this. You're going to have some declarations in the header like compare.h. And in a corresponding CPP file, you're going to have the definitions for whatever declarations you have in the header. But you don't have to do it this way. If it makes sense for your definition to show up somewhere else, please go ahead and do that. C++ is going to accept that. This is really all we set out to do in this lecture. But before we go, I'm going to give you a chance to set up another function. Suppose we have a function called anchor mult, and we're going to have the function set up in here. We're going to return a++. We already know how to do these things. We've used this example a couple of times by now, ++b, and that's what we're going to return. Now your job is to split this function into a declaration and a definition and put those in two separate files. One is going to be called operations.h and the other is going to be called operations.cpp. Pause the video, go ahead, set up your project like that and call that function in main CPP and see if you can pull that together. Okay, pause the video, do that, and once you are done, come back again and see how I do this. So we're going to set up a new file called operations here. It's going to be a header file, .h, and we're going to add another file called operations.cpp. That's going to be our CPP file, which is going to contain our definitions. We're going to go back in main and grab the entire function here. We don't want it in main. So we're going to go in the header here. We should go in the operations header. That's where we want this. And we're going to put in our definition. And we're going to put in our declaration. The declaration doesn't have a body, so we're just going to put a semicolon at the end here. You already know this. We're going to go in the CPP file and put in our definition. This is going to work. And to be able to use this function, we will need to include the corresponding header here. Why is this file called? Oh, it's called CCP. It's CPP. We're going to rename it. And we're going to change this to CPP. Okay, now we should be fine. We should have our things colored properly. And to use this function, we will need to include the corresponding header, which is operations.h. Let's do that. We're going to go in main and go down and include operations.h. This is going to work. And notice that the way we include our own headers is different from the way we include the libraries or headers that come with the C++ standard library. This is a convention that is used by many compilers. This is how we will have to do things. Please remember this. If you are including your own header, please put that in the quotes like we do here. If you are including a standard library header, please use angle brackets like this. Now that we have this included, we can go down here and say result. We're going to set up two variables, x and y. Why not? We're going to have a 4 here. And we're going to have a y, which is a 5. Let's do that. And we're going to have an integer to store our result. It's going to say anchor mult. And it's going to do the operations on x and y. Let's do that. And we're going to print the result here. So we're going to say result, and it's going to be whatever we have in that variable. Okay, if we build this program, it is going to work. We're going to use GCC to build. The build is good. If we run it, we should see our output here. I'm going to run rooster and the result is 24 because, okay, if we increment x, we're going to get a 5. And if we increment a 5, we're going to get a 6. If we multiply these guys, we should get a 30, and that's not what we have here. So what is happening? Let's look at our definition here. We said a plus plus. We should say plus plus a because we want to increment immediately. Okay, let's build again. We are going to build successfully, and we are going to clear and run rooster. Now we have the result that we expect. Let's go back in main and look at our program. This is what we are using here, and this is the output we expect. This is really all we set out to do in this lecture, showing you how you can set up your project to split functions across multiple files. This is really good if you want to organize your project. For example, somebody who comes to the header here is not going to be bothered by looking at all the definitions and the details of how we compute this maximum and minimum. And we have the flexibility now to move our headers in some other file because we really want to keep the main function or the main file here really clean. We don't want all those definitions to show up here because it is possible for your project to contain hundreds or even thousands of definitions. If you make all those declarations show up in the main CPP file here, that's going to be really hard to follow and work with. Now we have the flexibility to split those guys across multiple files, and we can even use lots of headers if that is what is going to work for our project. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to see how we can pass parameters to functions by value. Go ahead and finish up here and meet me there.